Welcome to our learning module covering the switch element of our Danfoss pressure and temperature controls. This is the part of the product that is responsible for changing the circuit configuration of the system in response to force from the sensing element. By the end of this session, you will be familiar with the contact system types available, as well as the principles of contact force and material, the load categories, EMC, and reset configurations. Any pressure or temperature control consists of three basic elements: the sensor element, the switch element, and the setting element. In this module, we will go through the switch element. There are a number of contact systems available in the industrial marketplace. Danfoss uses three types: single pole single throw, single pole double throw, and triple pole single throw. These are indicated by the Danfoss logo near the contact diagram. There are two contact systems used in Danfoss controls, Class A and Class B. The most common products in the control program have a Class A contact system. They are designed for high loads and a high number of switching cycles. Typically, the Class B contacts are micro switches, which are used when there is a limited number of switching cycles and low loads. Due to the compact design, they are frequently used where there is limited space. The switch contacts can be made of different materials depending on the application. The choice of contact material depends on the load level, load type, and switch frequency. The diagram shows the recommended contact material in relation to voltage and current load. The arrow pointing up and to the right indicates the number of switching cycles. In control applications, there are typically high switching frequencies. For this application, gold contacts are recommended if the electrical load is low. For high electrical loads, silver or silver alloy, AgCDO, is recommended. In monitoring and alarm applications, there are typically low switching frequencies, and therefore it is possible to have higher electrical loads when using gold contacts. Silver alloy, AgCDO, is the most common contact material for high electrical loads and high switching frequencies. When contacts switch on or off, electromagnetic noise is generated. Electromagnetic noise increases proportionally with current, voltage, and the power factor of the electrical load. The power factor is very important in relation to inductive loads, as a larger arc is produced. The noise emission spreads by the supply leads and electromagnetically by the air. This noise can disturb sensitive electronic equipment such as mobile phones, radios, and televisions. Electromagnetic compatibility, or EMC, is an essential quality parameter of pressure and temperature controls. Danfoss controls have good EMC performance and are compliant with international standards. Danfoss controls include products with automatic and manual reset modes. Automatic reset means the switch will cut back in automatically when the pressure or temperature returns to the required level. Manual reset means the switch will not cut in until the reset button is activated manually. Thank you for taking the Pressure and Temperature Control Switch Element module. Welcome to our learning module covering the sensor element of our Danfoss pressure and temperature controls. By the end of this session, you will be familiar with the different sensing technologies that Danfoss uses. We will also go through the control ranges, special features, and important things to consider when using different charges. Any pressure or temperature control consists of three basic elements: the sensor element, the switch element, and the setting element. In this module, we will go through the sensor element. Here are four of the most common technologies used in pressure and temperature switches. Danfoss uses three of these element types: bellows, diaphragm, and spring-loaded piston. These are indicated by the Danfoss logo. Most Danfoss controls use the bellows technology. Here is the range of Danfoss pressure switches, Danfoss differential pressure switches, and Danfoss temperature switches. Take a look at the table to see which sensing technologies and which accessible pressure and temperature range each type uses. In the RT and BCP series, Danfoss offers pressure controls with double bellows. The inner bellows, illustrated in dark gray, contains the pressure during normal operation. However, if this bellows fails and begins to leak, the medium enters the larger bellows. Because of the larger surface area, the same pressure generates greater force and causes the switch to activate. This protects the system by not allowing the charge to escape into the atmosphere. Danfoss thermostats function by creating pressure from a chemical charge in the sensing bulb. There are three different charges that can be used: the vapor charge, the partial charge, and the absorption charge. On the following pages, we will take a look at the advantages and disadvantages of each type. The advantages of the vapor charge are fast reaction, pressure limitation at over temperature, element pressure completely independent of ambient temperature, and very small sensors. The disadvantages are that units with this charge can be used only where the sensor is the coldest part of the element, and that the differential is also very dependent on the range setting because of vapor pressure gradient. The advantages of the partial charge are fast reaction charge and element pressure completely independent of ambient temperature. The disadvantages are that units with this charge can be used only where the sensor is the warmest part of the element, and that because of vapor pressure gradient, the differential is very dependent on the range setting. The advantages of the absorption charge are that the reaction is always in the sensor, the differential is mostly independent of range setting, and there is a quite good pressure limitation because of the low element pressure gradient at high temperatures. The disadvantages are that a low element pressure gradient most often means a slightly higher minimum obtainable differential, and that the element pressure is also affected by bellows temperature, which leads to a certain degree of capsule sensitivity. When using thermostats, there is a measurable delay between a change in fluid temperature and the response in the temperature switch. This is due to the time it takes for heat to transfer from the fluid through the sensor pocket and into the bulb, and the time required for the chemical charge to act. This delay is called the time constant. Thank you for taking the Pressure and Temperature Control Sensor Element module. Welcome to our learning module covering the setting element of our Danfoss pressure and temperature controls. By the end of this session, you will be familiar with the contact functions for control, monitoring, and alarm, as well as the differential switch and neutral zone options. Any pressure or temperature control consists of three basic elements: the sensor element, the switch element, and the setting element. In this module, we will go through the setting element. Danfoss temperature and pressure switches have a set point that can be adjusted by the user. On most switch modules, there is an indicator scale on the switch to aid in this. However, the values on the scale are indicative only. A thermometer or pressure gauge should be used to achieve the most precision. Additionally, on most switches, the differential is also adjustable. A larger differential results in fewer switching cycles and longer life. The graphs on the following pages show how the differential works in rising and falling pressure situations. Let's take a look at the cutoff for rising pressure. When the pressure exceeds the upper set point, contacts 1 and 2 break, and contacts 1 and 4 make. When the pressure falls to the lower set point, the contacts change over to the initial position. Contacts 1 and 4 break, and contacts 1 and 2 make. Let's take a look at the cutoff for falling pressure. When the pressure passes the lower set point, contacts 1 and 2 make, and contacts 1 and 4 break. When the pressure rises to the upper set point, the contacts change over to the initial position. Contacts 1 and 2 break, and contacts 1 and 4 make. The range and differential settings can typically be changed by either turning a knob or using a screwdriver. A differential pressure switch compares two pressures and acts on the difference in pressure. On the following pages, you can see a differential switch application and the contact function for falling pressure. Let's take a look at an alarm application for a dirty filter showing rising differential pressure. Contaminated oil gets into the filter. As the differential pressure rises over the filter, the differential pressure switch gives an alarm. Let's take a look at the cutoff for falling differential pressure. When the pressure passes the lower set point, contacts 1 and 2 make, and contacts 1 and 4 break. When the pressure rises to the upper set point, the contacts change over to the initial position. Contacts 1 and 2 break, and contacts 1 and 4 make. Some switches are capable of a neutral zone. This is when the switch gives no signal until the upper or lower limits are exceeded. On the following pages, you can see an example of a neutral zone application and a graph of the contact function. Let's take a look at an application for monitoring the air pressure level. When compressed air is supplied to the storage tank, the pressure increases. Then compressed air supply and demand are equal. When there is no demand for compressed air, the pressure increases in the storage tank and the air supply must be switched off. Let's take a look at the contact function for a pressure switch and a differential pressure switch with a neutral zone. Within the neutral zone, there is no contact between the connecting points 1 and 2 and 1 and 4. If the differential pressure rises above the neutral zone, contacts 1 and 4 make. If the differential pressure falls by the mechanical differential, which is fixed in the unit, contacts 1 and 4 break. If the differential pressure continues to fall beyond the neutral zone, contacts 1 and 2 make. When the differential pressure rises again by an amount corresponding to the mechanical differential, contacts 1 and 2 break again. Thank you for taking the Pressure and Temperature Control Setting Element module. Welcome to the Learning module on Pressure and Temperature Basic Applications. By the end of this session, you will be familiar with the definition of a pressure and temperature control, also referred to as a switch. The three basic applications are control, monitoring, alarm, and safety. Before we start looking at the basic applications, let's review the definition of a pressure and temperature control. A pressure control is an electromechanical device that opens and closes an electrical circuit when the pressure has reached a preset value. A temperature control is an electromechanical device that opens and closes an electrical circuit when the temperature has reached a preset value. In most fluid processes, temperature and pressure switches provide three main functions: control, monitoring, and safety. The control function is shown by the graph on the left. Switches are used in this function to directly control the pressure or temperature of the application by directly activating or deactivating components of the system. In the event that the pressure or temperature exceeds the limits intended by the system controls, it is common to use a pressure or temperature switch to activate an alarm system. This is shown by the graph in the center. If the application continues beyond the intended limits and becomes a safety risk, an additional switch is used to activate emergency shutdown procedures. Let's look at an example of a typical control function application. The burner starts blowing air into the burning chamber. Oil is sprayed into the chamber and is ignited. The heat increases and steam is generated. Steam vapor is generated and the pressure increases. The lower steam demand causes higher pressure in the chamber, and the control switches the fuel supply off. Now let's take a look at an example of a typical monitoring and safety function application. The first steps are the same as with the control function example. The burner starts blowing air into the burning chamber. Oil is sprayed into the chamber and is ignited. The heat increases and steam is generated. steam vapor is generated and the pressure increases. The lower steam demand causes higher pressure in the chamber and the control switches the fuel supply off. As the pressure keeps increasing due to excess heat in the boiler, the alarm switch is on. Thank you for taking the Pressure and Temperature Control Basic Applications module.